Okay, so today we will talk about factoring. So the focus of today's lesson is to solve quadratic equations using factoring. But before we move to the topic that the course is covering, solving quadratic equations using factoring, I wanted to do a short review on factoring. So we'll start with finding the greatest common factor between the terms. There are two ways that we can find the greatest common factor. The first one is by finding all of uh, the all the factors of each number and then see what is common in all of them. So for 16, what we would have would be 2, 2, 2, 2. And then for 24, I'll use another pen. For 24, what we will have will be, again, 2, 2, 2, 2. So 2, 4, 4, 4, 2, and 3. And for 32, what we will have is 2, 2, 2, 2, 2, 2, 2. So when we see this, the common factor for all of them is 8. So 2, 2, 2, 2 is common here, and it is here, and it is here. 8, including this one here. Okay. So the greatest common factor for those two numbers, greatest common factor, will be number 8. When we are dealing though with large numbers like the numbers that you have on example B, 990 and 2100, what I recommend is instead of finding all those factors is actually using the graphing calculator. And the way that you can use the graphing calculator is by selecting math and then going to numbers and picking the 9th option that you have there. And what you will do in this case, you will type the numbers followed by a comma. So on the first case, or on this case, will be 990 and the comma 2100 close brackets. The only upside of this method is that you have to take the numbers 2 by 2. So if you have more than 2 numbers, then you have to take whatever the greatest common factor that the calculator is giving you with a third number, and then whatever that is the result with a fourth number, and so on. So on this case of the between the two numbers 990 and 2100, the greatest common factor is 30. Now I will demonstrate shortly what do I mean by when we have more than 2 numbers. So on the first example, numbers 16, 24, and 32, what do we have to do is, so we have a case that we have more than 2 numbers. What do we have to do is select math, numbers, number 9, and then the calculator is asking us what are your 2 numbers. So you go 16, 24, and enter. So you have number 8, and then we'll take this number and again math, numbers, option 9, so will be 8, comma, and 32, close brackets, enter, and then the greatest common factor between those 3 numbers, 16, 24, and 32, is 8. So this is how you may figure out what is the greatest common factor between the 2 numbers or more numbers if you are having difficulties or if you are checking your work. Next example is dealing with coefficients and variables. So what the rule of thumb here is coefficients with coefficients, like variables with like variables. So between 6 and 8, the greatest common factor, oh, I have to use this, the greatest common factor between 8 and 6 is 2, because 2, 2, 2 are the factors for 8, and 2 and 3 are the factors for 6. And then the greatest common factor for x to the power of 2 and x. So this is what I mean by like terms. So we take x's, it's just x. And the greatest common factor, greatest, you have to excuse my writing. I don't like this, but y to the power of 3 and y to the power of 4 is y to the power of 3. So in terms of numbers, now you know, either using the calculator or using whatever, finding the factors, then you will find the greatest common factor. In terms of like variables, you will pick the one that has the lowest exponent. So in the case of x squared and x, the lowest exponent is 1. So this is why we have the greatest common factor as x to the power of 1. And between y to the power of 3 and y to the power of 4, the lowest exponent is y to the power of 3. This is why the greatest common factor is y to the power of 3. So the greatest common factor between the two terms, 8x to the power of 2, y to the power of 3, and 6xy to the power of 4 is 2xy to the power of 3. And now if we move to the next one, where we have 24 and 7, let's try the calculator for this. So let's figure out what is the greatest common factor of 20. Did we say 20? Yeah. So we'll pick number 9, and then we'll go 20, comma, and 4. So then we'll have 4, but we have another number that is 7. So again, repeating the steps, number 9, and then we'll pick number 4 that was as a result of the first two numbers, and number 7. Those brackets, and then we'll have 1. So between those three coefficients, 20, 4, and 7, there is no greatest, or the greatest common factor is 1. So there is no, we usually don't write number 1, so there is no greatest common factor. So greatest, oh, you have to use this, greatest common factor between 20, 4, and 7 is 1. And now greatest common factor between x to the power of 4, x to the power of 3, x to the power of 3 is x to the power of 3, the lowest exponent. And the greatest common factor of y to the power of 2, y, and y to the power of 5 is y. So the greatest common factor of the whole expression is x to the power of 3y. So if we have to factor out, then we will factor out just x to the power of 3 and y. Okay, so now this, as I said, this is a review from Math Fancy, but if you feel that you need this, by all means, take a look and continue. If you feel that you are okay, then what do you have to do is you have to move to the second part of this lesson. So on this case, we are factoring x to the power of 2 minus 2x minus 8. So what do we have to do is we have to take a look at the third term. So quadratic equation in general is on the form x to the power of ax to the power of 2 plus bx plus c. And the c is the coefficient that doesn't have any variable on it. So on this case, we have negative 8. So the products, we have to look at the factors of negative 8 that when we add them together gives us negative 2. And those two factors are negative 4 and 2, because the sum of the two will be equals to negative 2, which is the b term of this quadratic function. And then when we are writing this quadratic function in factors form, what we do is we take those terms, so negative 4, and we write them as two monomials. So in this case will be x minus 4 brackets x plus 4, x plus 2, sorry. So you just take those two terms and then you kind of replace them into those two values. Next one is x squared minus 12x minus 28. And then again, we have to find two terms, two factors of that. When they are multiplied, their product is negative 28. But when they are added together, the product is positive 12. And those two numbers are 14 and negative 2. When you multiply those two together, 14 times negative 2 will give you 28. And when you add those two together, you will have 12. So then when we write them into quadratic, or sorry, factored form, then we will have x plus 14 x minus 2. I hope that you understand this. Let's move to the next one. So we'll have x squared minus 5x minus 24. So the term here is minus 24. The two factors of negative 24 that gives us negative 5 are negative 8 and 3. So then this will be x minus 8, x plus 3 in factored form. The next one is x squared plus 10x plus 16. And the two factors of 16 that gives us 10 will be 8 and 2. So then this quadratic equation in factored form, if this helps you, this method, which I've seen it sometimes, so you write them into two brackets and then you will add here whatever are the factors of C term that when you add them together gives you the B value. But we know that the quadratic function is not all the time in the form just x squared, but we will have that a term here. So on that case, what do we have to keep in mind is that we have to multiply A and C together. So when we multiply them, we will have negative 30, multiply them. And what we have to do now is we have to find the two factors of negative 30 that will give us, and this is not an, okay, well, that will give us 13, negative 13. But none of those gives us negative 13. So therefore, we can say that this is not factorable. Okay. Now, if we move to this one here, what we have is we notice that we have a greatest common factor, between 20, 70, and 60. So 20, 70, and 60 is 10. So this will be the very first step for us. We will factor out the greatest common factor. And this will end up being 10, open brackets, 2x squared plus 7x plus 6. And then what we do is we multiply those two together, 12, and find the two terms that the sum of them is equal to 7. And what we are doing on this case is we are using that method that is known as the decomposition. So what we are doing is we are finding that those two terms are 4 and 3 because the sum of them will be equals to 7. So then what are we doing on that case is we are decomposing the x term. So then we will say 10, 2x squared plus 4x plus 3x, plus 3x plus 6. And we will factor by grouping. What do I mean by this? So in between those two groups, x squared and 4x, the common factor is 2x. And then what is left on this case will be x plus 2. And then between those two other terms, what is common is 3. Oops. And what is left when we are taking away 3 as a greatest common factor is x plus 2. So now, in between those two, we have a common monomial. This monomial here and this monomial here, which means that we can rewrite this as 10 x plus 2, if we factor out the monomial, 2x plus 3. This method is known as the decomposition method. So let's do another example. On this case here, we have 15x squared minus x minus 2. So let's multiply the 15 and negative 2 is negative 30. The two factors of negative 30 that gives us negative 1 are 5 and negative 6. So now this tells us that we have to decompose plus 5x minus 6x minus 2, the b term. So because this is pretty much, again, negative x. So then we will group them 2 by 2. This one and this one, and this one and this one. So now, between those two terms, what is common is 5x. So this will be 3x, okay, plus 1. And between those two terms here, negative 6x and negative 2 is negative 2. So when you take away negative 2 from negative 6x, you will have 3x. And when you factor out negative 2 from negative 2, you will have plus 1. You can check it by foiling up. Now you have two monomial that are common, so then 3x plus 1 times 5x minus 2 will be the factored form of this quadratic. Now, if we move to the next one, or last one of this, which is known as the decomposition method, again, we see that we have a value that is not 1, but you can use this logic even for a equals to 1. The product of the two is 24, and the two factors of 24 that gives you negative 14 are negative 12 and negative 2. So now let's decompose minus 12x minus 2x plus 3. Between those two terms, what is common is 4x. So you will have 2x minus 3. Between those two other terms, what is common? What is common is negative 1. So you will have 2x. If you factor out negative 1 from negative 2x, you will end up having 2x. And if you factor out negative 1 from 3, you will end up having negative 3. So you will have two common monomial. So 2x plus minus 3 and 4x minus 1. Okay. The last slide is dealing with special polynomials. So what do you have to keep in mind on this case is you have to see if each of those terms is a perfect square, and if it is subtracting. If it is adding, then you cannot do anything with it. But if it is subtracting, then yes, you can. So on this case, the square root of x squared is x, and the square root of 4 is 2. So then you can rewrite it into x minus 2, x plus 2. And if you can check it, if you do FOIL, then you will have the same expression as x squared minus 4. And on the second example, again, we have 4x squared. The square root of 4x squared is 2x, and the square root of 49 is 7, and we have the negative here. So then we can write them as 2x minus 7, 2x plus 7. So this is what you have to keep in mind. And even when we have just two variables, we still will have to do the same thing. So we'll have the square root of x to the power of 4 is 2x squared, and the square root of y squared is y. So this will be 2x squared minus y, 2x squared plus y. And the last one, again, we'll check it if it is the perfect square. So square root of 36x is 6x, and the square root of 1 is 1. So this will be plus 1. I hope that this is enough for review.